So let's get started. This is Stat 20. Did I turn my mic? I did, but can you hear me in the back? Let me turn it up a little. How's that? Is that any, there we go. Is that, you can hear me all right? All the way, back row, hello. Can you guys hear me? Yes? All right. So this class is an introduction to statistics, and I will be learning a whole lot about data. And rather than go through all of the course logistics right off the bat, I thought we would start by collecting some data and then figuring out how these data that we're collecting are different from each other. So I'm going to start surveying you right away. This is confidential. In fact, could I ask you to help me hand these out? I'll give you some. And could I ask you to help too? And how about, could I ask you to help? Why don't you start at the back? And could I get you to start at the back too? And here, just toss these around. All right, so there's a survey coming around that I'd like to get your information from. Oh, could I have a copy? Thanks. So we're going to fill this out together so that we know how to answer some of the questions. I'm going to switch over to the document camera so you can see my survey right here. And we can start filling it out together. Hopefully you can read that. Oops. It has a... First question, how many ounces of soda did you drink yesterday? So fill that in terms of number of ounces. I had a can of soda for lunch that I believe was 12 ounces. Next question says, what's the span of your right hand? And so to answer that question, flip the page over, and you'll see a centimeter ruler on the back of this paper. And the span is the distance from your thumb to your pinky when it's fully extended. So I see that mine is just about 20 centimeters. And it asks you to record it to the nearest half centimeter. So I'll put 20 in for my hand span. The next question says gender, male or female, circle 1. Next one says, what time did you wake up this morning? And to the nearest 15 minutes, I'll put my answer in. So the little colon, hour, colon, minutes. So we know you guys must be relatively early risers if you're here for a 9 a.m. class. Rate Toy Story. Rating from 1 to 4. Stars or have not seen it. I have not seen Toy Story. And finally, what's your middle name? That's my middle name. All right, so has everybody completed their survey? Yes? All right, what I'd like you to do now is just turn to your neighbor, introduce yourself, and pick a question. And what I want you to do is try and figure out how would you summarize the data. If you had all of the sheets of information from all the people in the class, what would you do to summarize the data? And so, in fact, rather than letting you just pick a question, I'm going to assign different rows to questions. That way, we'll be sure that we have them all covered. So I have 6 questions. So I'm going to split it. This half of the class will do the first 3, and you will do the next 3. And let's say the first 4 rows or so will do the first question, the next 4 the second question, the last 4 the third question, the first 5 the fourth question, the next 5 the fifth question, and you guys in the back on the right the 6th question, and you guys in the middle do whatever you want. Introduce yourself to your neighbor and brainstorm a little bit as to how you might summarize these data. Okay, you got 5 minutes to do that. What question do you guys have? You're number 1?
Yeah, we're number 1.
What are you thinking about?
Gather all the data, put it in a list, and take a median.
Okay.
Is that what you're looking for? Or
Yeah, that's fine.
Okay.
How are you guys doing? So what are you looking at? Gender? Oh, hand span? Good. So what are you thinking of doing?
Graph.
Making a bar graph? Okay. How are you guys doing? Which one are you working on?
Toy Story.
Toy Story. So I see that's your idea of, good. What's the height of these represent?
Number of students. We also do a pie chart, which would be percentages.
That's right. Yep.
Are we supposed to collect the data first and then see the relation between number 3 and with each other?
Just number 3. Just work only with number 3. And what might you do with number 3? All right. Good. Sounds like you've got some discussions going. I'd like to ask you, I know you've been looking at one question, but I have a question for you. How are these questions different from each other? I chose these 6 questions very specially. Each one is slightly different from the other, not just in, of course, one's asking for your gender and the other's asking if you like Toy Story, but they're very different from each other in terms of the sort of kind of data that is being collected. So question 1, folks, how's your data different from another question? So I have a mic. So let me say, they're recording this class as it's going on, and you hear my voice off of this microphone, I hope, and either the document camera or the PowerPoint is being displayed. So there's no video aside from what's on the screen. And I wanted to hear you guys as we record the class. So I have a mic. And if you're really shy, you don't have to answer a question on the mic. But otherwise, I'd like you to use the mic. So, all right, so you were about to say something.
It's either quantitative or qualitative.
It's either quantitative or qualitative. So I'm going, and what's your name?
Karen?
Karen. Karen says it's either qualitative or quantitative, and I'm going to say, what does that mean? Anybody want to say what you think? Well, give me an example of, is yours the answer to question 1, qualitative or quantitative?
Quantitative.
Quantitative.
Yeah.
What's one that's qualitative?
Female or male? Gender?
Okay, gender. Does anybody agree or disagree with Karen? Yes?
I agree.
And you are?
Adrian?
Adrian? And what question were you working on?
2.
Which is?
Hand span of right hand to the nearest half centimeter.
Okay, and was yours qualitative or quantitative?
Quantitative.
Okay. Who did a qualitative one if you are thinking that there's a difference between qualitative and quantitative? Yes? And you? Which one did you have? That's you're kind of far away for me to get the mic to. Question 3, which was what?
Which asked about gender, male or female,
Gender, and that is not quantitative. Why not?
because it doesn't have to deal with numbers,
It deals with what?
categories.
Categories or
Or
qualities?
qualities.
Good. So that's great. That's the first thing that we recognize as the difference between some of these 6 questions. We're now going to look at them in a little more detail, because I'll say that there's still an even finer distinction between these variables. So we've now said that they're either qualitative, measuring qualities, not numeric or categories, or they're numeric or quantitative. So if we look at these 6 questions, let's decide on each of them. Number 1, we've been told, is quantitative or numeric, as is number 2. Then, was it Eric? What was your name?
Oh, David.
David. David said that gender is qualitative. How about number 4, the time you woke up this morning? So that's you guys. What do you think of your question? Is it qualitative or quantitative? Yes?
It's quantitative.
Quantitative? Right. How about your rating for Toy Story? That's that group. What do you think? I know some people in this group. Tony, what do you think? Is it qualitative or quantitative?
Qualitative?
Qualitative. It's got numbers, 1, 2, 3, 4 stars, but we don't really think of that as really a numeric response. We think of it as sort of a whether you really liked the movie or didn't like the movie. So I would agree with you. How about the last one? Is that data? Is that what we think of as data? Asking your middle name? Yes? In the back? Yes, yes. And what kind? Qualitative. And how would you summarize that data?
Just a plain table with people's names and their middle names. Just a table with people's names and their middle names listed.
And their middle names listed?
Yeah, so that when viewed, you can shape that data into anything else you want to.
From there. So
Yeah,
your
from there.
starting point is to make a table of all the names that we've seen for all the students in this class. And then from there, we might see if there are duplicates and figure out what other kind of representation we have. That's great. So let's continue. So as you see already, you've already made this distinction, quantitative versus qualitative. I'm going to go one step further and ask you to compare gender versus Toy Story. You've said that these are qualitative. They measure qualities. They're categorical. And I'm going to say, what's the difference? There's still a difference between these two variables. Yes?
Male versus female is objective. Rating Toy Story is subjective.
So we heard that male versus female is objective, and rating of Toy Story is subjective. That's right? That's a difference between them. What's another difference between these two? Yes?
In a way, the movie ratings are ranked, while you wouldn't really want to rank male versus female.
That's right. In a way, the movie ratings are ranked from lowest to highest, and you wouldn't really want to say male is higher or lower than female. So there's an ordering. One more difference. Were you going to say something? No? One more difference. Yes?
Male and female is clearly defined, whereas the stars are more of an arbitrary.
Right. I think that's what you had meant by subjective. That's right. One seems like you're clearly in one category, another, and other people can see determine whether you're in one category or another. And whereas the Toy Story rating, it's my rating for number 4. What I would call a number 4 movie might be very different from your number 4 movie. And what about just the sheer number of categories? Male versus female, there's 2. That's sort of a binary. Whereas Toy Story, how many categories do we have? 5, because we're including those who haven't seen it as a category. Great. So how about handspan versus the time you woke up this morning? Are they essentially the same? There's a very subtle difference between these two quantitative numeric measurements. Yes?
I think that the centimeters, it really depends on the person, but minutes, because it's a 9 a.m. class, there's a certain time slot where people woke up to get here.
So, I would argue that, so did everybody hear her? She said that, because this is a 9 a.m. class, you kind of know some sort of boundaries on what time you woke up. Hopefully you've woke up earlier than 9, since this class starts at 10 after 9, whereas the handspan...
The handspan can really differ because...
The handspan can differ more. I would say there's also a limit on handspan size. Would you say that as well?
But I think that the boundaries might be a little bigger, that's all.
Uh-huh. Well, in fact, it's hard to compare them because it's sort of like apples and oranges. There is a hard boundary if you're here that you definitely were up by 9 a.m. How about somebody different? I've heard from you two already. Someone else want to say what's different about them? Yes?
Handspan might be bimodal between men and women.
So you're thinking about the distribution already? She said, Go ahead.
Oh, handspan might be bimodal between men and women, whereas the time you woke up might be more constant because people
Might not be as gender related. That could be. What you're getting into is how the distribution might look. My question actually is more of the nature of the information that we've collected. So let me ask you a question. Does it make sense to say my hand is half the size of your hand? Does it make sense to say I got up half as early as you did? No. So there's a distinction between those kinds of numbers. We call the first one, where we can say I got up, or my hand is 10% bigger than your hand. We call that a ratio type of numeric variable. And the one where it doesn't make sense to do that, but I could say I got up an hour before you did. So I can look at the difference between values, my value and your value. That is an interval type of quantitative measurement. So we're looking at slightly finer ways of describing data and kinds of measurements. For quantitative, we can say that they are interval or ratio, depending on whether or not it makes sense to say something is a certain percentage bigger or smaller, or if it only makes sense to look at differences. And then qualitative, we have ordinal and nominal. Ordinal is Toy Story, where you can order the 1-star, 2-star, 3, 4, means that you like the movie. If you rated it 3, you liked it better than if you had rated it 2. Whereas male and female is not ordered, it's simply named or nominal. So let me ask you this, your middle name, which of those 4 categories does it fall into then? Nominal, right. We're not ordering names yet. Okay, so essentially this is what we just said, that quantitative ratios are numeric values when there's a meaningful distance, and the ratios such as twice as big make sense. Whereas interval are also numeric values, but there's no natural zero or lowest value that you could make comparisons against. An ordinal, comparisons in terms of ratios. An ordinal is a qualitative category that has an order and but no meaningful way to measure the distance between one and the next one higher. And nominal is categories and there's no meaningful order. Great. So the reason why we're talking about this is because depending on the kind of data you've collected, you would analyze it differently. So that's a common mistake that most people make when you go about creating summaries of your data. If your data are ordinal, you would do a certain kind of summary that you wouldn't do necessarily if you had nominal or, ratio or interval data. Okay, so I'd like to go back to the document camera and ask you now, for those people who are looking at the handspan, so we're going to talk about graphics next week, so we're just going to get started here. And I'd like to ask you how you might summarize the data in a graphical format as a figure or a plot. And let's just look at handspan. So I'm going to turn the document camera on, and I'm going to ask someone to come up and actually try and sketch it, and then we can discuss it. So questions you might think about for those who are dealing with handspan is, what would go on the x-axis? What do you think the shape of the distribution of handspan for this class might look like? Do you think there are really long tails or short tails? You mean, does it drop off really quickly, or does it go out for really far? And will there be, someone's already said that, will there be one or two peaks if we look at the distribution? Will it look like a bell curve? So those are the kinds of things you might want to think about when you come up here to draw your picture. So do I have someone who's willing to be a guinea pig and come up and show us how they might sketch this? Okay, yes, and your name? David. David. We've got a few Davids here. Come on down. I'll move this up, and you can make a sketch right there at the bottom of my survey. And whatever we say, don't worry, don't take it as a criticism. We're going to get to how we would really do this later on next week. I want you to do it on the document camera so that we can all see it. So here's a pen. Go for it. So David's drawing the y-axis and the x-axis. Could you label the x-axis for us? Yeah, we're watching you. Okay. So what are you putting on the y-axis, David?
Number of people.
Number of people? Okay. And how about the x-axis?
That's hand length.
Okay. Handspan? Does everybody agree with him so far? Is that a good way of going about trying to summarize this with a picture? Putting handspan on the x-axis? Maybe? Someone would do it differently?
I probably do a little more descriptive. I put handspan in centimeters.
Right. Yes. So look at that. He's getting there. Good idea. You put handspan in centimeters. That's good. Okay. Anybody else have comments? Yeah. We're getting to the hard part. What do you think that would look like?
Well, I noticed. Should I start at 0 or should I start at?
good question. The question was, should he start at 0? Let's take a vote from the group. Should he start at 0? The people up, Karen says, no way. Why not?
It would be meaningless if it's 0, because most likely people in this room, their hands would start somewhere like at least above like
Above 0. Right, right. What do you? Somebody shout out a number. Where do you want him to start?
10.
Wow, 1, 10, 16. We've heard 3 different.
15.
15. So think about how big your span was. Let's think about my span. Mine was 20. Does that help you?
Yeah. I mean, I don't think it's going to get much.
What was your span?
22.
22. Our hands are, I thought I had small hands, but I think that they actually stretch out a lot. So go for it. Doesn't matter. Well,
I'll go with 12.
he's going with 12. All right. So we're making the x-axis, and so he's putting it in increments of 2 centimeters. Okay, now sketch what you think that would look like.
Basically a double bell curve.
A double bell curve. So one bell curve for the females and one for the males kind of overlapped. Is that what you're thinking? Okay. Does anybody think that won't be a double bell curve? No, go ahead. Doesn't matter. Go ahead. Write it. Anybody? You're all convinced? David, the other David, not the one drawing, does not think it'll be a double bell curve. Why not?
Because the extremities of the females will enter into the same area as the lower extremities for the males.
And they'll add together?
So they'll add together, and it'll look more trapezoidal than a camel.
Okay. That's a good point. You know, there are some, well, we will see. I'm going to collect all your data in a minute, and then hopefully I'll have it all summarized for by next week. But very good. Thank you. Let's give a round of applause for David. Good sport. That could very well be what it looks like. So you're using some information that you've had from other times you've seen data. And I would say you're using 2 things. One is that you think that, and rightfully so, that things that are sort of grow naturally, often the measurements of them, length, heights, whatever, follow a bell curve. And that's a pretty good assumption to make. And you're also thinking, well, males and females might have different bell curves. Females tend to be smaller than males tend to be. And so then there might be a bell curve for the males and a bell curve for the females. And when you sort of put them together, you might not get a bell curve, but you might get something that has 2 bumps or bimodal. Sometimes if they overlap quite a bit, you'd still get just 1 bump. All right, let's go back to my questions. And look at the next one. How would you summarize the soda question? Now, this is not a summary of the soda question. This is just extra information to help you figure it out. And I pulled this off the web, and it's there's the URL from nationmaster.com, and it puts the United States as number 1 in terms of the amount of soda that's drunk, I believe, that's annually per person. I know, some of you are shocked. That's right, 216 liters per person per year.
That's kind of. I know people that don't drink any soda at all. That's a lot of soda.
Very good observation. So, what's your name?
Eugene.
Eugene, say it again.
I know people that drink absolutely no soda, and that's a lot of soda.
And that's a lot of soda.
No, and I know people that drink only soda that don't like the taste of water. It's
There we go.
weird.
Okay, so do you want to be a good sport and come up and draw what you think that distribution might look like? No? We can ask someone else. So this information should help you sort of figure out, and Eugene's comments, that he knows some people that don't drink any soda at all, and others that sort of drink a lot. So let's go back to the document camera and have Eugene sketch, just roughly sketch what you think that distribution might look like. And let's help him out here. What do you think goes on the x-axis? Amounts of soda. We're measuring it in ounces, not liters. So let's put ounces of soda on the x-axis. And then don't bother with the y-axis. Oh, you want to do liters? Okay. All right. But this is just for yesterday. Our question's different than the one where I showed you the response to. It wasn't what's our annual consumption. It's how much did you drink yesterday? Hello, Eugene? Yes. I said our question is how much did you drink yesterday?
Oh, okay.
And so,
we're talking about the other one.
No, we're talking about this class of 125 people or so. So it's ounces is your measurement, unit of measurement. Good. Okay. So how would you represent what you were saying of, a lot of people who drink no soda, and some people who don't drink water, only drink soda. So does that sound like the bell curve to you? Sounds like the bell curve to you? I saw you nodding yes. Yes? No? No? And you are?
I'm Warren.
Let me put the mic on. Warren, what do you have to say?
If we looked at the that original thing where it was U.S. drank lots of soda and the other countries drink less, if you expanded that list to include like third world countries, it would start to look exponential.
Yeah, but there's a difference here between what I'm asking you guys to draw and that chart I put up, and it's particularly confusing. That was something about U.S. and other countries. So that was comparing countries. We're now here in the U.S. You are all here in Berkeley, California, in the United States. And we're looking at individuals, like how much soda did you drink yesterday?
I drank zero.
He drank
I think
zero.
that our line, it
Yes?
would be particularly representative of this exponential idea. One person drank 5/6 of the soda of the entire line.
What do you think an exponential looks like?
I think it looks like this.
Goes up?
Yes.
Okay. So we've got, let's just put some, thank you, Eugene.
Oh,
Let's give Eugene a round of applause. Eugene drew a normal curve, and I forgot your name already. Warren wants it to go up as we go like this. How about someone else? Yes, you are? Jeff?
If the y-axis is the frequency of people, like the number of people who drink that many ounces,
Yes.
there should be a lot of peaks because a lot of people don't drink any soda, or some people don't drink any soda. We consume soda in certain set quantities, like 8 ounces.
Like you get a can of soda and you drink the whole can, whether or not you really want a whole can of soda. Okay, come on up here. Let's see what you're talking about. I'd like you to just draw it right on top. Just sketch it real quick. So what Jeff was saying was that because soda tends to come in fixed quantities, 12 ounces, 16 ounces, or whatever, he thinks that they're going to be it's going to be kind of lumpy, the distribution around those values. And did you draw that thing on the edge?
Yeah.
And what is that?
People who drink like zero soda or like a bit of soda.
Okay, good. All right, so there's a bump at the very beginning for the zeros, and then this peak you're saying is what? What's that? This one. Or a can of soda. So, okay, and this one is maybe 2, like 16. Okay, great. Well, to be continued. Do you all want to vote of what you think it looks like? You want to make a comment?
Yeah, I want to defend the bell curve.
You want to defend the bell curve, okay?
While it may seem like a lot of people absolutely drink only soda, and a lot of people drink zero soda.
Right.
I think most people fall somewhere in the middle.
Uh-huh.
between the bell curve.
Okay, and now this is drinking soda just yesterday as well. Let's just take a straw poll. How many people in this room drank no soda yesterday? Wow, look at that. I would say that's 2/3 of the class. I think Jeff nailed it. But to be continued. All right. All right, so I'd like you, we can't lose your data, or we cannot confirm that all of these hypotheses that we've made about the distributions of the responses. So if you could all pass your papers to the center and then down to the front, and we'll collect them. And while you're doing that, I'm going to ask you a question. We've already said we think middle names are data as well, and that they're qualitative and they're nominal, not ordinal. And so that's great. I'm glad you recognize that. And in fact, there's a website, Baby Name Wizard, where for prospective parents who can't figure out what they want to name, so they don't have their mother-in-laws and fathers and et cetera saying, you've got to name so young after Aunt Sadie or whatever, and they're trying to figure out how to name their child, they can go and take a look at names from the 1880s until the 2000s. That looks kind of hard to figure out. If you're interested, take a look at this website, and just to show the kinds of things you can do is you can you can type in the letter S and see all the baby names that start with the letter S. You can restrict it to be only boys or only girls or both. I typed in SA, and you can see over from the 1880s to the 2000s how, if you take a look at the blue Sam and Samuel, that Samuel was popular, then lost popularity in the 1940s and has gained popularity now. I was interested in that because my son is named Samuel, and when he was in kindergarten, there were 3 Sams, and when I was growing up, there weren't any Sams. I put my name in it. Do you guys have a guess what my name, Deborah, would look like if we typed it in, the full name, Deborah? Is there any Deborah in the class here? Okay, that's one data point for you. And are they my age? Like your mom's or your grandmom's age?
Younger than my mom, like maybe I think she's in her like
Early 40s. Okay, so that sort of gives you an idea. It's rather amazing. I know there aren't very many now, but it was flat in the 40s, 50s, 60s, real big peak, and then down again, and nobody's naming their, or very few people are naming their kids Deborah. So you might go to this place, babywizard.com, and type in your name or other names, etc. The other thing that's kind of fun to see is you see boys' names becoming girls' names. You'll see a lot of that, and it doesn't so much go the other way. Okay, so the point of this class is that, some of you have emailed me already and said, what's the book for the class? There is no book. I'm working on getting you a reader, and there's a reason why there's no book. And that's because statistics has changed so much in the last 10 years, and the books have not kept up. The books are all about statistics that you would have done 40 years ago. And data everywhere. If you're interested, you can do a Google search on it. The Economist had a 16-page report on how science and business is changing dramatically, has changed dramatically in the past 5 years based on the sort of proliferation, the easy access, the amount of information that's being collected and made available in all different professions. And at the same time, computers have gotten so much faster and bigger that you can store so much more data and process it more easily. Has really made a profound impact on the field of statistics, and I would like to get that across to you in this class and let you experience what sort of modern data analysis is all about. And just to give you a few examples, the Sloan Digital Sky Survey that was came on board in 2000, taking pictures of the sky, trying to create a whole survey of all the stars in the sky. And within 1 week of operation, it had collected more data than from the entire history of astronomy. Sequencing the human genome took 10 years the first time. Now they can do it in a week. There's all sorts of biological data available on the web in databases now for people to analyze. Project Gutenberg, like the Gutenberg Press, Project Gutenberg is an online resource. You can get incredible amounts of historical information through Project Gutenberg. Like every single State of the Union address from all the presidents in the United States is just one example. Zillow, has anybody heard of Zillow? Yeah? And that is what? Real estate. You can look at you guys, you can look at your homes. You can type in your address. A picture of your home will come up and an estimate of how much it costs, how many bedrooms, etc. I did that for my house and found out that I had 5 bathrooms in my house that I only ever knew about 2 of them. But so there's all sorts of information, not necessarily really accurate information about homes across the United States. Netflix, you all know about Netflix, right? So the idea about rating Toy Story is really familiar to you if you use Netflix. Netflix has lots of information that it collects, and it has a recommender system so that the next time you want to go and add a movie to your queue to have it sent to your home, it says, hey, people, you like this movie, so we think you'll like that movie. That's a recommender system based on analyzing all sorts of your recommendations and other people's recommendations for movies. And Facebook, I read the other day, has 4 billion photographs on it. And that was several months ago. It might be 8 billion by now. So the world has so much data, and it's really different data than we've ever been able to analyze before. So coming into this class, you might have thought that data are just numbers. And so hopefully going out of this class, you have a better sense of what data are and what the possibilities are for analyzing and getting information and meaning from these numbers. All right, now we're making a transition to the syllabus for the course. There are 5 basic topics that we're going to cover, or 5 chunks, I would say. It's not necessarily that these topics have to go together, but I've chunked them for our sanity. So we'll spend about 2 to 3 weeks on any one chunk. The first one, which we've started already, is graphics, descriptive statistics, and exploratory data analysis. That's the kind of way of taking a look at data without getting into formal modeling. And you can learn a lot through exploratory data analysis. You can learn a lot through a very well-made graph or plot. And so we'll be spending probably 3 weeks on graphics and exploratory data analysis. And by the end of 3 weeks, you'll be amazed at the beautiful plots that you can make. And you'll be making them not by hand, as we just did on the document camera, but using the statistical software program R. Okay, next is experiments, hypothesis testing and randomization. So we'll spend some time looking at the kind of data that come from designed experiments and how you go about designing experiments. Next, we'll cover probability, and we'll learn something about random variables, and we'll be doing lots of simulations. So we'll be studying how some processes work through using the computer and simulating that, and then studying the results of the simulation. We'll go on to survey sampling, and again, methods for making extrapolations to the general population from a sample through computational methods called the bootstrap. And we'll also be creating confidence intervals. And in the final part of the class, we'll be looking at observational studies, which are neither designed experiments nor survey samples. And with those data, we'll enter the world of modeling and regression. So those are basically the 5 areas that we'll be covering. And how are we going to actually manage the class? You all have probably been notified that a BSpace account has been set up for you for this class. I'll be putting lots of the course resources, and all of the class assignments are going to be through BSpace. The textbook, there is no formal textbook. There will be a reader made up of chapters from various books, because there's no single book that sort of covers the statistics and the approach that I would really like to. We'll be spending a lot of time with case studies. So we'll be looking at stories of, we'll probably look at 10 to 12 stories this semester in terms of real applications, real world applications of statistical data analysis to solve some important question. So part of that reader will be a set of case studies to read. We're going to be using the R software, and what I'd like you to do this weekend is to install R on your computer. If you have a laptop or a home computer. We have R installed on computers in the statistics department on the 3rd floor of Evans Hall, and you are welcome to use those. You will all be getting an account for this class so that you can use them. But if you have a laptop or a home computer, I really advise you to install R. And let me check the time. Yeah, we have a few minutes. Oh, very few minutes. I want to quickly show you a little bit about R. We have 2 GSIs, Wayne and Harry, and they're great. Wayne and Harry are 3rd and 4th year students. They're very experienced. They know a lot about R. They've had lots of experience being GSIs. I particularly asked for people who are really experienced because of the nature of this class, not having the standard typical book and sort of going through homework problems. Section is required. You have sections of size 25, and you'll be doing lots of hands-on work, either solving problems on the computer or on paper in sections. The office hours will be announced, and my office hours might change. I've got to talk to, let me introduce Mike in the back. Mike, stand up, say hello. Mike Leong runs the math part of the Student Learning Center, and give your spiel.
We're going to provide drop-in tutoring starting 3rd of the semester. Will be Monday through Thursday from 10 to 4. So we'll be on drop-in tutoring where you can just come in and get individual help. Deb will be holding office hours shifts, and we'll talk a little more about
Right.
changing swap.
Right, so some of my office hours will also be at the Student Learning Center, and we're still negotiating when I'll have my office hours there versus in 395 Evans, which is my office in Evans Hall. Very quickly, here's the layout of the percentages. Yes, question?
Where do we get the R software?
Online, and I'm running out of time, so you know what? I think we'll have to postpone that till Monday. What I was going to do is do a demo with you, and if you want to bring, might be hard having everybody trying to download it online at the same time, but let me say this. If you're already really familiar with downloading software from the web, go to Google, type in the letter R. The very first or second, typically the very first response up is to R, the software, and then it's free. It's free. Yes. And then this is the distribution of homework, etc. So everybody have a really good weekend, and I will see you on Monday.